Hey guys, it's Coach Zane here, and in this video we're going to be learning the flow control tab in EV3 MicroPython. So what exactly is flow control? Well, as the name suggests, flow control actually allows us to have more control over our programming in EV3 MicroPython. And in my opinion, flow control is one of the most important tabs or skills you can learn in not just MicroPython, but also Python or Java or any sort of programming language in general. So in the flow control section of programming, we're going to be going over three different things. The first one is going to be loops. Now, loops simply allow us to do repetitive tasks over and over again. The second one is going to be if/else statements. So if/else statements, basically, they're just decision making of the robot. So if something happens, then we're going to do something else. If that something doesn't happen, we're then going to do something else. So that can be a little bit of a mouthful, but basically it's going to be the decision making of the robot, and we'll be able to program this in. Okay, let's head over to the laptop now and we'll see how to actually program our flow control into the robot. So as you can see, I've got my desktop open and I'm going to navigate to Visual Studio Code once again. And I will open up a new project. Before I do that, I'll open up the user guide because it's always important to have the user guide open. Today we're going to be learning mainly what we did last time, but we're just going to be applying flow control to it. However, it's good to have the user guide open anyways. And I'll navigate back to Visual Studio Code. I'm then going to open up a new project, and I'm going to call my project flow_control. And I will call it that and save it here. Okay. So as always, this is what's going to open up. To get to our programming environment, hit main.py once again. And once we do that, we have all of this here. So the first 8 lines, as always, don't touch it. The next few lines, today we're going to be programming our motors with flow control. So we then need to initialize our motors. And to do that, as discussed in the previous video, I'm going to quickly go through it. So EV3 brick, that's already been initialized for us. So thank you Lego for that. We're then going to initialize our left motor. So I'm going to put left_motor. You can call the object name whatever you want, just as long as the actual class is exactly the same. So as we learned in the last video, to initialize your motor, you just need to hit motor. You then need to specify the port which your motor will go into. And to do that, open your brackets and write port, followed by whichever port it is. And for me, my left motor is in port B. We're then going to copy paste this command just to make it easier for ourselves for our right motor. So just change this left to right. And our right motor is in port C. So that's what we're going to do. Now, if you have any other, make sure it's capitalized so it's going to work. If you have any other motors, you can add them to your initialization process. For the process of this video, I'm just going to be using our left motor and our right motors. However, one more command we do need to write down is our drive base function. And if you remember from the previous video, drive base is essentially going to allow us to move the left motor and the right motor simultaneously. This is important to move straight and to make turns. So to do this, I'm going to write down robot, which is what my object name is, followed by capital D, drive, and then capital B, ASE. And I'm going to open up my brackets. And the parameters for this is first your left motor. So left motor, and this is going to link up straight to this object here, which is my motor B. I'm then going to write down my right motor, so space, right motor. You don't really need to worry about your spaces, however, if you're picky about them, you can. Python doesn't really recognize spaces anyways. You then need to put your wheel diameter, and for me, my wheel diameter is 55.5. In the previous video, when we mentioned what this was, it's just essentially the diameter of your wheels. So equals 55.5. And lastly, we're going to put the axle track. Axle_track equals 104. Now these numbers, they're not very important. However, they do allow you to measure your distances and your turns exactly as you want them. So if you are picky about having exactly the numbers you want, then you put these numbers in. However, if you're happy to just trial and error until you reach the correct distance, then it's okay. You don't really need to worry about these numbers. Alright, and that's the complete initialization process for this video. So we're then going to move on to our program here, and as always, we'll delete this beep because it's useless to us. Okay, and now we're going to move on to the first of our flow control components, which is loops. Now, loops, they essentially repeat an instruction or a line of code over and over again. And you can have multiple lines of code within a loop. Now, in Python, to create a loop, you would use a word operator. And this word is called while. So I'm going to write down while, and you'll see, as we mentioned in the first video, special operators are actually in purple. This is because they do something different to normal words. So while is going to be the operator we're going to use to create loops. And there are two types of loops you can essentially create. The first one is a forever loop. So for example, if you want to do a task forever, for example, if you wanted to create squares with your robot forever, you will then type while followed by the word true. Now, essentially, this is just going to be a period or a line of code completed forever. And this is occasionally important because we will use this while true function in certain videos. Okay, however, for our purposes, we're actually going to be using something else to control our loops. So our loops will be controlled mainly in this video by our motors. And I'm going to head over to our documentation here, and I'll show you the commands you need to measure down the distance that your wheels will carry over. So to get to that, all we need to do is head over to the robot tab. And we then need to keep going, and as you can see, you can actually measure the distance that the robot drives. You can measure the angle that it drives. Distance and angle are essentially the same thing. So if you want to go a straight distance, that will be a certain number of millimeters. But that corresponds to a number of rotations, or 360 degrees times how many rotations you want to make. So distance and angle, they're the same thing. They just measure how far the robot goes. For this video, we're going to be using distance because it's more inherent to understand. And another function we're going to use, I mentioned it in the previous video, but this robot.drive function, you can see that you first specialize a drive speed followed by a turn rate. Now, if you want to drive straight, which we are in the next example, we're going to specify the turn rate to 0, and then we can give the drive speed. The question becomes, how do we control distance with this drive operator here? And the answer is using a while loop. So a while loop will repeat a function for a given parameter, and we're going to set that parameter to however much distance we want it to do. So I'll explain what this is. I'm going to combine all of these components now. So I'm going to use this command here, followed by this command here. So I'll go back to Python and we'll see what this looks like. So I'm going to type while robot.distance, and this is going to measure the distance that the robot does in millimeters. And now I'm going to use a special operator that's called less than. Now less than, this robot distance is going to give us a number. And to control the while tab, we're going to do less than a certain number of millimeters. And I'm going to do 300 millimeters, which is roughly 30 centimeters. So all we need to do is now type in what do we want to do while the robot is going less than 30 centimeters. This might be a little bit fuzzy for now. However, with time, we'll see what this actually means. Now, very important with most of your flow control, you have to make sure you type in a colon. So if you don't type a colon, it's going to return a syntax error and your program won't work. So make sure anytime you use while, you have a colon there, so it's going to work. Also, your while, as you can see, once we type stuff into this while, it's going to be a slightly indented tab. The reason why there's indentation is because we need to tell the robot or the programming what actually falls under the while. So if I keep continuing, and I'm just going to write gibberish for now, you can see basically this line will continue vertically downwards until we end the while loop. And to tell Python that, okay, now I'm going to end the while loop, I'm just going to hit backspace and then continue. And you can see that's where the while loop ends. So make sure you have your common indentation. If you copy paste, you can see how many space tabs you have. So we have 1, 2, 3, 4. And if there's even a space off, it's going to return an error. So make sure all of your indentation is consistent, and that's what's going to be contained within our while loop. Okay, so what do we want to do in this while loop? Well, as I mentioned, the robot.drive function will actually move at a straight distance for a given speed. So I'm going to write robot.drive. And if we go back to our documentation, what is in robot.drive? First, it's a drive speed, which is measured in millimeters per second. And then it's our turn rate. So as I said, our turn rate is going to fall to 0 because we want to go straight for now. So we just need to specify our drive speed followed by a 0. And my drive speed, you can play around with whatever speed you want to get to, but I found that 250 is a nice and steady speed. It is a little bit on the slower side, but we'll see how we go. and make sure you specify a turn rate, and because we're not turning, I'm just going to make that 0. And delete all of this gibberish here. Okay, so before we continue, let's explain what this actually is. This is essentially going to allow us to move our robot straight for a given distance for a given speed. So with our robot.straight function we did last week, you saw that basically all we needed was a distance and it would work. However, we couldn't control the speed. But with this robot.drive, we can specify a speed, but we can't specify a distance. So to overcome this issue, all we need to do is set up a while loop. So while the robot distance is less than 300 millimeters, we're going to drive straight at a speed of 250 millimeters per second. Now you might be thinking, okay, how does it know to stop? That's because if it's driving forward and forward and forward, eventually it's going to reach that 300 millimeters. Once it does, then this while loop is going to escape because the condition of the while loop is satisfied. So once it hits 300 centimeters, it's going to say, okay, now that I'm not less than 300 centimeters, what do I do next? And to end our program, we're just going to make the robot want to go straight. So I'm going to do the 3 commands that we learned last week. Robot.stop, left motor dot brake, and right motor dot brake. So once again, just to explain the whole program, all this is, while the robot is going to target a distance, it's going to go straight for a given speed using robot.drive. Once that distance of 300 millimeters is then covered, the while loop is going to be satisfied and it's going to move on to the next line of code, which is robot.stop, followed by left wheel brake and right wheel brake. These 3 lines are just going to stop the robot from moving. And now using this program, we can now control distance and speed of the robot. And that's much more comprehensive than the previous straight function that we used in the last video. So let's see what this looks like. So you might be asking, okay, that made it go forward. What happens if we want to make it go backwards or correspondingly in a different direction? Now, this can be a little bit hard to understand because the mathematics isn't very inherent to our brains. However, if you want to go the opposite way, we then need to go greater than a negative value, and we need to change this sign to negative. So just to explain this, if it went forward first, it's now going to go backwards. However, if it goes backwards, it's going to register a negative degrees, which means we need to keep on going negative until it's greater than a certain negative value. And that's why we put negative here and here. If that doesn't really make sense, try it out and see if it works. Once it does, then you understand, okay, now I need to change these signs. In general, you can just memorize that to go the other way, just flip the sign and apply negatives to the distance and the speed, and you should be all good. So this was a very simple example of how to use a while loop. In future videos, we're going to learn mainly how to do it with our gyro sensor as well as the light sensor, because that's going to be using our sensors to be able to control certain things. And this is going to be the more advanced programming that we'll get to soon. Okay, so that was a while loop in a nutshell. Just to go over it, it's just going to repeat an action for a certain parameter. And in the example we used the parameter of distance to control how far we want the robot.drive to go. Okay, now let's move on to our second flow control component, and that is if/else statements. As previously mentioned, if/else statements simply ask a question to the robot. If that question is true, for example, if I hit the brick buttons, then something else is going to happen. If that question is false, then I'm going to go into the else tab and complete something else. So I'm going to now delete this and show it. If that doesn't really make sense, then I'm going to explain it with the programs, and after we do a couple of examples, hopefully it'll become clear. So to first actually start our if, we're going to need to have a while loop, which is why we did while first. So I'm going to write while.true. I'll explain why we need to do this soon. Make sure you have your colon. And once you do that, we're going to see that it's not indented. The reason why there's no indentation is because we made a mistake. While actually doesn't need a space. So that's why it's turned to purple. And now when we hit enter, we should see an indentation. I'm then going to do if, and as we mentioned before, if simply asks a question. And the condition we're going to use is if the brick center button of the brick is pressed, then we're going to move straight. Now, how do you write that in Python? All you need to do is the following command. Button dot center. Now, because this is an American produced programming language, we then need to make sure we have it in the American term. So the T is going to be followed by the E and then the R. Whereas in reality, if you have in England or in Australia, you have the R and then the E, but make sure you have it as the E and the R because it is case sensitive. And then we're going to do if button center in EV3 dot. Now this EV3 is essentially the EV3 that we initialized at the start of the program. Dot buttons dot pressed. Now, just to explain where this comes from, all this is asking is if the center button is pressed, then do something. Where did I find these commands? If you go back to the documentation and you go to programmable hubs, you can see the buttons pressed is here. And if you go down to the list of buttons, you can see these are the list of buttons that I actually can recognize. And I've chosen this center button here because it's normally the easiest to connect or to hit. So once we're happy with this, all this question is asking once again, if I press the center button, then do something else. Now the question becomes, what do we want to do? And I'm just going to do a very simple example. Make sure you have your colon once again. So colons are important when you have ifs, also when you have whiles. And once we hit enter, we should see another indentation because the if has its own loop or its own sort of compartment within the while loop. So once we enter, as you can see, there's another indentation. Make sure all of your indentations are consistent. And then we're going to do robot.straight. And I'm going to specify a target distance of -200 millimeters. So what I'm going to do is I'm first going to run this program and let's see what it looks like. Okay, now what exactly did this program do? So it might not look like it did much, but essentially it was waiting. It waited until we then pressed the middle button of the EV3 brick. Once we hit the middle button of the EV3 brick, then it went to go on straight. Now, if we just left it and we didn't press it, it would have been waiting forever until the battery died. So this is important because this allows the robot to make a decision. You might be saying, all right, well, the decision was based on our influences, but in future videos, we'll actually learn why this decision making is important and how to let the robot, in a way, make its own decisions. Okay, so just let's explain the program once again. If the center button is pressed, then go straight. That's very simple to us, right? Because we know we've briefly explained each component by itself. But why is the while true there? Well, the while true is there because we need to continuously ask the question. To best explain this, what would happen if the while true wasn't there? Well, as we explained in the first video, programming is just a set of lines and instructions. So it'll do one line followed by the next, followed by the next. So if we run this program right here, once it gets to line 22, it's going to ask, is the button pressed? And obviously, unless we have our hands on it before then, it's not going to be able to recognize that I've pressed it. So it's basically just going to skip over this line here and move to the next one, which is not what we want. We want to continuously ask the question, is the button pressed? Which is why we need this while true loop here. Okay, and the last thing I'm going to do with this if/else statement is actually explain how to do something else. So if you hit enter here, and let's go backspace, if I hit else, you can see it comes up in purple, and then we're going to hit a colon, and now you can see it's created another indentation similar to the if right here. So what is this else? Basically, if the center button is pressed, it's going to do one action. If the center button is not pressed, it's going to do another action. So it looks at the if condition. If it's false, it'll then go to the else tab and then run that decision. If it is true, then it will run under the if. So this is the decision making of the robot with two cases. And for our example, I'm just going to do robot.turn just to differentiate our two commands. And I'm going to put 1,000, which is quite a lot, but it's essentially just endless donuts. Okay, so let's briefly explain what this actually means. So essentially, it's going to ask, is the center button pressed? Now, obviously, if we haven't got our hand already on it, then it's going to move straight to the else tab. And the else tab just tells it to do donuts. So it's going to do donuts over and over and over again. And then once I hit the center button, then it's going to say, okay, this if is then satisfied, and it'll just move down to this one here. After this is completed, it's going to ask the question again. Is the center button pressed? Obviously, if my hand isn't on the center button, it's going to say no, and it just keeps on doing donuts. What this means is it'll keep turning. When I press it, it'll move straight. After it completes that straight, it'll then keep turning again. And let's see what this looks like in the program. Okay, so if you're thinking like a programmer, you might be saying, alright, well that's two decisions that the robot can make. What would happen if I want to make more than two decisions? And in reality, a robot can make up to 1,000,000 decisions at the same time at once. And how do we actually do that in MicroPython? All you need to do is, in between if and else, there's a special command you have to do, but you have to make sure it's aligned within the if and else, and it's called elif, E-L-I-F. And essentially, this is going to be another command. So elif, and then you can do button dot right. Make sure all your right is capitalized because that's what the documentation states. And then you can just do in and copy paste this command right here. So this now has three conditions. If the center button is pressed, we'll do something. If the center button isn't pressed, we can write another command that whatever we want. And if neither of those are true, then we'll go to this else statement here. And the good thing about Python is you can have as many elifs as you want. So you can have endless decision making of the robot, which is quite useful and powerful. And this is why I said that flow control is one of the most important tabs, is because this decision making of the robot is going to be consistently and important in FLL competitions. Now, I'm not going to do an example of this elif because it is quite complex, and in reality, there's only one specific example of the game day program that we'll do in the future. So when it comes to that, then I'll explain the application of this elif. You can dream up any scenario you want. So go ahead, try different scenarios, do multiple cases, and this is all going to improve your programming in the long term. Okay, so as I mentioned, that was the second component of flow control. Now, thankfully, the third component is much simpler, it's much easier, and it's only one command. So the first component was while loops. While loops repeat an action over and over again. The second component was if-else statements. If-else allow decision making of the robot, and if you have more than two decisions, you can do elif, and this will create multiple cases. Our third component of flow control are wait blocks. Now, wait blocks essentially, as the name suggests, it just allows the robot to wait for a few seconds. So I'm just going to do an example of this very quickly. If I want to go straight, I have two options now, right? Because we learned that you can use the drive function, which is robot.drive, which has a specified speed, or you can use the robot.straight function, which doesn't have a speed, but it has a distance. So because the robot.drive allows me to control speed and distance with a while loop, I'm going to use that. So I'm going to do while, and as we did in the previous example, distance. So make sure it's all written correctly. And this distance actually won't work because you have to do robot.distance because you have to assign it to an object that you want the command to run over. So while robot.distance is less than, actually I'll do greater than in this example, just to help with going straight because my robot moves forward with negative power. And make sure you do your colon. If this happens, I'm going to do robot.drive, and I'm going to do -200 like last time, and my steering target is 0. So just to explain this again, this is the while example that we did in the previous few minutes. So while the robot distance is less than a certain value, we're just going to move straight. Once that distance is hit, the while loop is unsatisfied and we'll move on to the next command. And I've specified a target speed of -200 millimeters per second and a steering power of 0 because we want to go straight. Okay, so once this is completed, I'm then going to do robot.stop, and if it's capitalized, that means you made a mistake, so we need to put brackets, and then left motor dot brake, right motor dot brake. And as we explained in our previous few examples, this is just going to put the robot to a braking stop as opposed to a gradual stop. And now I'm going to do a special command. So I'll go back to documentation and show where I found this command. Essentially what it is it's going to allow the robot to wait for a few seconds or for a desired time. And to find this, you just need to go to timing and data. And the first command right here, wait. So it pauses the program for a specified amount of time, and that program or that pause is measured in milliseconds. So for example, if I want to wait for 2 seconds, that's actually 2000 milliseconds. You can use Google or an online converter, but all you need to do is multiply your seconds by 1000 to go from seconds to milliseconds. So I'm going to then wait for 2000 seconds. And this is now controlling our program. So that's why it's under the flow control tab. Whereas it's not as advanced as the while statements or the if-else statements. And after I wait for 2 seconds, I'm just going to do a simple robot.turn, and my turn angle is going to be 200 degrees. Let's see what this looks like. So as you can see, all this program did is it moved forward at a specified speed using the robot drive function. It then stopped for 2 seconds. That might not have been really apparent. If you go back, you can actually see you can time 1, 2, and then it made our turn. You can change this 2,000 to 5,000 to 10,000, whatever you need to make the robot stop. You might be asking, why is it important to make the robot stop? And the answer to that is sometimes you want the robot to breathe, to have a little bit of breathing room in our competition. So which is why it's important to have our wait time on seconds. Okay, now that wraps up the flow control tab. So just to briefly explain, we went over the while function, if-else statements, and wait blocks. Now, it's completely understandable if you didn't really understand what's going on the first time around watching this video. So you may need to watch this video multiple times. It preferably took me a couple of months to really understand the while loop when I was learning it. So it will take you the same amount of time or even less, you know. It just depends on your programming ability. At the end of the day, the harder you work towards something, the better you can do it. So don't be demotivated by what we learned. Just if you are struggling with it, then keep having at it and ask questions. Let me know in the comments below if you have any concerns and I'll try to get back to you. Apart from that, that's it for this video and I'll see you guys in the next one.